here's what I think happens with galaxies. Okay. What you have is, I really can't draw galaxies at all. This is pathetic. Okay. What you have is a galaxy. Okay. Here's the core. Here are the outer bands. It's a big spiral-like object. Looks like a hurricane. I obviously can't draw one very well. But there are events which occur inside of this hurricane. I would consider those events to be like an oak tree growing acorns. The stars, obviously all the billions of them, are the leaves. So you have the leaves, and you have these right there, and the acorns. Okay? The leaves dissipate the energy of the tree. The acorns give the tree the ability to reproduce itself. Okay? What I think happens is inside of an active galaxy, the acorns eject. They leave. They leave along, I think it was the minor axis of the galaxy. Here, let me go ahead and draw a picture of that. Okay, say you have a galaxy. Now this is the axis of the spiral arms, the X, Y, Z. Now, I think, here are the arms, whatever. I think the quasars are ejected along the Y axis of the galaxy, so they go shooting out these two directions, along where the magnetic field of the galaxy is, in this direction where it's easier to escape. And I think the reason why they eject is because these quasars, their magnetic fields themselves are really strong. So they fall out, they just get out of the way. So once these quasars leave the host galaxy, what happens is they grow into galaxies themselves. So they just eject matter in bilateral configurations. Here's the next step. Here's a big curve. And before you know it, it's this giant spiral galaxy with all these arms. And it grows, and it gets older, and then it ejects quasars itself when it starts dying. So basically you have the galaxy, circle of life, I guess you could say. Now, what's fascinating to me is that astronomers, they called pulsating stars pulsars. They're pulsing stars. And they think they're just these rapidly spinning objects, and they emit beams of electromagnetic radiation. Okay? They're spinning really rapidly according to astronomers, and they're really, 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 really dense. And their magnetic fields are fantastically huge. The magnetic fields are really, 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 really strong. This adds more lines in there to show how strong this magnetic field is. Okay? Let's go ahead and do that. That's a pulsar. The big mistake I think astronomers made was assuming that a pulsar equals a star. I think that's wrong. I think a pulsar is a baby quasar. A pulsar is a brand new galaxy. This object right here contains all the information, or soon-to-be information, of an entire galaxy. This is galactic DNA, if you will. You study pulsars and understand how they work, like the Crab pulsar, the Vela pulsar, and you really come to terms with what that object is doing, and I think you'll have the future in your hands. And no, I am not exaggerating. Those objects are the most powerful, most mysterious things in the entire universe. We've already explained stars. The star cools, dies, shrinks, becomes life-hosting star. No big deal. These objects, I think my listeners should study in depth. Those are the future. Okay.